Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydroboration-oxidation 1. B2H6 2. H2O2 O is an anti-Markovnikov, SY addition of water across a double bond. The boron adds to the less hindered, less substituted carbon, and after oxidation with H2O2 the O ends up on the less substituted carbon. Moving on to the next step. Identify the starting material. The alkene shown is 2-methyl but 2Na-CH3 to C is equal to CH-CH3. It has 2 carbons in the double bond, C2, bearing 2 methyl groups, more substituted, and C3, bearing 1 methyl and 1 H, less substituted. Moving on to the next step. Apply hydroboration radioselectivity. Boron, electrophilic, bulky, adds to the less substituted carbon, C3, placing H on C2. After oxidation, O replaces B at C3. And for the final step, determine the product. O ends up on C3 of the original alkene, CH3, to CH-CH of CH3, which is 3-methylbutane 2-ol. This matches option B, a saturated alcohol with O on the internal less substituted carbon. Eliminate other options. Option A retains the double bond and places O on the more substituted carbon. This would be a Markovnikov type or allylic product, not from hydroboration oxidation. Option C shows an epoxide, which is not the product of hydroboration oxidation. Option D shows O on the more substituted carbon, Markovnikov product, which would result from acid-catalyzed hydration, not hydroboration oxidation. Therefore, the correct answer is B. Therefore, the correct answer is option B.